Hi, it's Mrs. Moss here, and today we're moving on and talking about sedimentary rocks. This picture of the Grand Canyon is actually a picture of an area that was made entirely of sedimentary rocks. Here's another gorgeous picture of it. So what are some of the general characteristics of sedimentary rocks? Well, sedimentary rocks form from sediments, and we learned that fragments of pre-existing rocks like pebbles, sand, silt, and clay are considered sediments. These rocks form at the Earth's surface where weathering, which is the breaking down of rocks, can occur. Sedimentary rocks often form thin horizontal layers. We call these layers rock strata, or sometimes they're just called beds. And most sedimentary rocks form under large bodies of water, like lakes, seas, oceans, etc. Here's a picture that shows the beds or the rock strata, the layers that I was telling you about. It's a great picture, and you can even see the sediments at the base of that mountain. So there are two types of sedimentary rocks. We have first a clastic sedimentary rocks, and they form from the compaction and cementation of fragments of rocks, which are known as clasts, such as pebbles, sand, silt, and clay. Compaction is sediments that are squeezed together under pressure. And cementation, just like the word cement, it's when the particles get glued together. So through the process of compaction and cementation, we form sedimentary rocks. Now the two common natural cements are calcite and quartz. Here's a picture of the pressure that happens under compaction, and you see in the diagram that the fluid is squeezing out. Fluid that was in between any sediment is now out of there, so it allows for quartz, calcite, and other cements to bond and hold those sediments together, forming its own new rock. Here's a picture of a sedimentary rock called conglomerate. Now you can see there's mixed particles and they're cemented together. And the rock actually looks like this. This is another picture of a conglomerate. It's pretty cool. You can see all of the sediments and the different sizes and the way that they're cemented together. So how do we classify sedimentary clastic rocks? Well, we look at their texture, and the size of the sediment is the main factor that we use. So for example, if a rock is composed of sand-sized particles, the rock is a sandstone. And in clastic sedimentary rocks, the mineral composition is not important. It's really the sediment size that is important. Here's a picture of sandstone. You can see the small fine particles of sand that make that rock. It's formed from the compaction and cementation of sand. Siltstone, an even smaller particle, is held together from parts of, guess what? Silt. Makes sense. And then we have shale. Well, shale is actually a compaction of clay. So although you don't necessarily see the individual grains like we do with sand, because clay particles are very small, all together those pieces come together to form this rock. That's shale. And here's just an up-close picture. You can see the layers of shale and how it's been created over time, and it creates this layering effect. Just as we saw with that larger rock, that mountain, you could see the layers. This happens too with shale as it's being made from clay. So the other type of sedimentary rock that we have is bioclastic. And if you see the word bio means life. So bioclastic sedimentary rocks actually are composed of fragments of organic remains like plants and animals, clasts that have been compacted and cemented together. Limestone is formed from an accumulation of shells and animal skeletons. And coal is formed from the remains of trees and plants that have been accumulated in layers and buried deep under the ground, and it's been compressed for so many millions of years it actually forms coal. Here's a picture of a fossil limestone, and you can see the shells and the fossil remains are in the rock, and so that rock is a sedimentary rock known as fossil limestone. Here's another picture of the fossils in a rock. And here's a picture of limestone that has been formed from the shells. And you can see it's literally the fragments of shells that are cemented together. Here we have the chalk cliffs of England, just another form of sedimentary rocks. Again, chalk cliffs of England. This is entirely made of um, chalk or rock gypsum. Here's coal, forms of decaying plant material. This is what the actual coal sedimentary rock looks like. And here is a sedimentary rock strata that has coal mixed in with it. You can see the black lines going across that layer is coal layer. Our next type of sedimentary rock is rocks that are made from crystalline or chemicals. Now, we talked a little bit about this when we were talking about deposition, but these are formed from minerals that were once dissolved in water or solution, like halite, which is known as salt. Salt is dissolved in water and then it evaporates and leaves behind solid salt. Here's a picture of just the seawater evaporating, and what's left behind from that seawater is collections of salt. The result is that the salt that's left behind will form a crystalline rock with mineral crystals. Here's a picture of what I'm talking about. This is a salt deposition on a desert lake floor, and you can really see the whiteness that has taken over. It almost looks like snow, but it's actually salt. And this is just a picture of the rock salt that forms from that mineral and from those precipitates that are left behind. This is known as halite. So let's talk more about how this is formed. The process by which the dissolved mineral comes out of the solution is called precipitation. Minerals that were once dissolved are called precipitates or evaporates. And the crystalline sedimentary rock is made up of only one mineral, and so we call that monomineralic, which means mono, which means one, and mineral, so it's one mineral. Monomineralic. And here's a picture of the salt beds. Actually, this may be, and I don't know for sure, but it might be Salt Lake City. Salt Lake City is known for these salt areas. Here's a picture of stalactites and stalagmites. You may remember they're formed from the calcification and the carbonic acid that drip and eat away underground. Well, this is all part of the process of how these crystalline structures and these crystalline sedimentary rocks are formed. So here's rock gypsum. It's formed from the mineral gypsum. Summary: sedimentary rocks form horizontal layers beds on the Earth's surface, sometimes known as rock strata. Mostly they're made up of sediments that have been compacted and cemented together. Only one type of rock, sedimentary rocks, contain fossils. Why? Because they form at the Earth's surface where the animal remains can be easily buried and compacted with sediments. Some sedimentary rocks are organic and composed of fossils. And there's one more that we want you to write down. Sedimentary rocks contain fossils. You already wrote that, but here are some cool pictures of fossils. And the Eurypterid is the New York State fossil. Please make sure to write this one down in your summary. This is a picture of the Eurypterid when it was alive on the right, and this is a picture of it, let me go back, and this is a picture of it as it was fossilized in sedimentary rock. So within the Earth's crust, we have relative amount of igneous and we have some sedimentary rocks. As we learned about before, igneous rocks are made from lava and hardened lava cooling and solidifying. In the crust, underground, you would imagine we have a lot more igneous rocks because that's where all the magma is. So if you look at this pie chart on the left, the sedimentary rocks are a very small amount under the ground. 5% make up sedimentary rocks, but under the ground, 95% is igneous. On the surface, we have 75% as sedimentary rocks, and at the surface, 25% are igneous. And as I said, it should kind of make sense because under the ground is where all the magma is, so that's where we'll have the predominant igneous rocks. And also on the surface, that's where all of the weathering occurs. So the weathering produces sediments that create sedimentary rocks. So some of this should be logical, but we do want you to write these down in your notes in the percentages. Okay, So this is a picture of the reference table. This is page 7. Just jot down page 7. And what you'll see is it's broken up into the two types of sedimentary rocks. We have inorganic or the clastic, and then at the bottom we have the chemically or organically formed sedimentary rocks. And this chart is a lot easier than the igneous rock chart. We're just going to really look across the chart and see what it lands on. So when we look at it based on grain size, we have the pebbles at the top, and we can tell from going across what each of those grains, what type of sedimentary rocks they will produce. Okay? Looking at this again, if you look at the bottom, and I'm ignoring those questions at the top for right now, I just want to show you what the pictures are. If you look at the bottom, you can see that they have the chemically and organically formed sedimentary rocks. Crystalline texture, and if you go across, you see it creates rock salt, rock gypsum, dolostone, and the bioclastic, which have the remains of shells or plants, and that's limestone and coal. So we're going to stop there for now. You do have some review questions that are on your sheet. You don't have to answer these right now. We're going to go through them in class tomorrow, and we're going to go through this chart a little bit more in detail if you didn't pick it up for now from the screencast, okay? But right now, just go back, make sure you have all of the notes taken, and we'll see you tomorrow. Bye.